Welcome back, everybody. Section 12.5, last section of Chapter 12. Okay, last section of the semester, and actually geometry for you for this year. Okay, so you've made it. We're almost there. One more thing we're going to talk about with circles. That would be circles in the coordinate plane, as in the XY axis. Okay, objective today is to find equations of circles in the coordinate plane. Here we go. Alright, so first off, let's give you the formula, okay, for the equation of a circle in the coordinate plane. Okay, so the equation of a circle with center HK and radius R is given by this guy here. So what we're talking about is XY axes. If I have a circle where the center is at the point HK, just randomly somewhere out here, and then the radius is R, so the distance from center of the circle to any point on this circle is the R. And then my formula for that, we'd say this is in standard form, is x minus h squared plus y minus k squared is equal to r squared. We'll show you how to use that in a minute. As far as where this is coming from here, basically it's just the distance formula. If I want to know the distance from the center to the side of a circle, you don't need to copy this down. I'd say d is equal to square root of, I suppose we'll do it without the specific stuff here yet. It is x1 minus x2 squared plus y1 minus y2 squared. Okay, if I fill in things from this specific circle, that distance we could just say is r is equal to square root of, I'm going to say x minus h. If this is my x1, this is my x2. And then same thing, y minus k. If this is my y1 and this is my y2. And then the trick here is, if I square both sides, okay, which would get rid of the square root on the right. Okay, there you go. There's my standard form equation. Okay, so really this equation is just coming directly from the distance formula. All right, so let's show you how we can use this equation. First thing is to take a point and a radius and actually write the equation. So part A says, what's the standard equation of a circle with center 5, negative 2 and radius 7? Okay, well, the formula we just gave you is x minus h squared plus y minus k squared is equal to the radius squared, where h is the x coordinate of the center, k is the y coordinate. All we're going to do here is just really fill this in. So we'd say x minus 5 squared, okay, plus y minus negative 2, in other words, plus 2 squared, is equal to the radius 7 squared. And I suppose instead of 7 squared, we could just say 49. Okay, that's it. That's a standard form equation. Okay, that's going from a point and a radius to an equation. B is the same idea. Why don't you take a minute, pause the video, fill in B, and then press play to check your answer. Alright, so filling things in, we have x minus the x coordinate 3 squared, okay, plus y minus the y coordinate is equal to the radius squared, which in this case would be 36. All right, in problem 2, we're going to do the exact same thing, except for this time we're not going to be given the radius. We're going to be given another point on the circle. So we're going to have to actually solve for the radius. Part A says, what's the standard equation of a circle with center 4, 2 that passes through the point 2, negative 3? Okay, so I've got a picture for this one. We don't actually need it, but just to help you explain what's going on here. We know our standard form equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Okay, so filling in what we know, we've got x minus the x coordinate 4 plus y minus the y coordinate 2, both those are squared, is equal to the radius squared. And the thing is here is I know my center, but I'm not sure what this radius is here. So that's what we got to solve for. That's what we got to fill in with this one. Okay, now radius is defined as just the distance from the center of the circle to the edge. So if I know the coordinates of my center, and I know the coordinates of a set of coordinates of any point on the circle, we can figure out that radius using the distance formula. Okay, distance formula is d equals x1 minus x2 squared plus y1 minus y2 squared. And really, the distance formula is just a variation of the Pythagorean theorem, something else we've done this semester. Okay, so filling things in, let's go ahead and do that. X minus x, doesn't matter what order we do. I'm just going to go 4 minus 2 squared. Okay, plus, then in the same order, we'll go y minus y2 minus a negative 3, in other words, 2 plus 3 squared. Okay, so d is equal to square root of, let's see, 4 minus 2 is 2. 2 squared is a 4. Okay, plus 2 plus 3 is 5. 5 squared is 25. All right, so in other words, we could say d, or our radius, is equal to the square root of 29. All right, now I'm not actually going to plug this into the calculator. Here's why. If I take that radius of square root 29 and then square it, because remember it's radius squared, I actually end up with a nice number as I run out of room here. I'll just go down here. So my final answer then is the x minus 4 squared plus y minus 2 squared is equal to square root of 29 squared, in other words, just a 29. All right, so there's my standard form equation. Part B is the same idea. It doesn't give you a picture, but it gives you the same center and point on the circle. Why don't you take a few minutes, pause the video, work through that one, and then hit play to check your answer. All right, so once again for B, we've got to fill in the x minus h squared plus y minus k squared is equal to r squared. Okay, filling that in, we'll have x minus 4 squared plus y minus 3 squared is equal to the radius squared, which we're not given. Okay, to find it, though, I can use the 2 points, the center and the point on the circle. We can use our distance formula. D is equal to square root of x1 minus y1, x1 minus x2 squared plus y1 minus y2 squared. Okay, so d is equal to square root of, that's going to be, we could say, 4 minus a negative 1, so 4 plus 1 squared. All right, plus 3 minus 1. And that's going to give us square root of 4 plus 1 is 5. 5 squared is 25. Plus 3 minus 1 is 2. 2 squared is a 4. Looks like we get square root 29 again. Probably mix that up so it's not the same both times. Plugging that in, I have a square root 29 squared, which will just turn into a 29. So we've got a x minus 4 squared plus y minus 3 squared is equal to 29. All right, there's my standard form equation. All right, last thing we're going to look at is graphing a circle based on a standard form equation. Okay, so problem 3, part A says graph the circle given this is the equation of the circle. Okay, so now we know our standard form equation is x minus h squared plus y minus k squared is equal to the radius squared. Okay, now to graph a circle, we need to know the center and we need to know the radius. Okay, for the center, what I have is just the h and k from this equation. So I'm going to say my center is a positive 3 and a negative 2. And the reason that switched signs from the equation to the actual point is since it's x minus the h, I know the h will be the opposite of whatever sign we have here. Okay, because if it's x minus 3, that means the h is 3. And if it's y plus 2, since we're subtracting, I know that has to be minus a negative 2. All right, so there's my center. We'll go over 1, 2, 3. Looks like we're counting by half units. And down 2. Make my center right there. And then the radius is going to be the square root of whatever number we have here. Okay, so in that case, that's square root 36. In other words, just the 6. And I have to take the square root because it's not just the radius at the end of the equation, it's the radius squared. Okay, so if the radius is 6, what I'll do is I'll count out 6 units in each direction. Okay, so we'll count out 2, 4, 6, and make a point. We'll count up 6, 2, 4, 6. Count left 6, 2, 4, 6. And down 6, 2, 4, 6. And then best I can, I'm going to connect these dots to make a circle. I missed. Let's make the dot bigger. Alright, there we go. You get the idea. Same idea for problem B. Why don't you pause the video, figure out the center, figure out the radius, graph that circle, and then hit play to check your answer. Alright, let's go through B. Center is going to be at positive 2, negative 1. Switching both those signs. So let's go right 2, down 1. Again, counting by half units. And then the radius will be the square root of 9, in other words, a 3. So if I count over 1, 2, 3, up 1, 2, 3, left 1, 2, 3, and down 1, 2, 3. Okay, again, counting by half units. And connect the dots. My circle will look something like that. Alright, there you go. That's it for geometry, actually. So, good work. Make sure you get through the homework. Make sure you're asking questions if you need it. And we will see you folks later.